All right, hey, this is gonna be the new style of Imagen videos. I'm actually gonna start doing these. It's gonna become more of like a devlog on what I'm building, kind of just walking through some cool code. And as you can see here, we're talking about some C today. I've been working on this little bad boy right here, little handheld game console, and I've gotten it up to about 700 frames a second, making small updates, kind of coming up with my own little algorithm using direct memory access and all that nonsense. So I thought I'd show you that today. But first, I wanted to just stop here at the very beginning of this whole little thing that we are talking about, which is to say that why does C have a more robust type system than Go? It is a little emotionally painful that I can just do like tagged unions. I know I have to do like a little bit more hand rolling of it, but it's just like, man, that's offensive. You know what I'm talking about? All right, so let's talk about this. Let's talk about what I'm building, how we're building it, and all that crap, okay? So let's do a new one of these little screens. Let's zoom it in and let's bring it in. Okay, it's whiteboard time. So this thing's called an ES Play Micro V2. I'm not a hardware guy. I guess technically my very first job was building government funded robots. So I did do hardware at one time. I've written an Ethernet driver, my own video protocol, and a flash driver. But look at this, and a planetary pancake motor driver. But that was also like 15, 18 years ago. So am I still good today? I don't know. Anyway, so I'm starting to play with this guy right here, which is pretty fun. I don't know how a lot of it works. It's already all pre-made. It has a battery. So I'm not doing any of the actual hardware side, more of just like programming against the hardware side. And so I've had some fun trying to play around with that screen because it turns out that screen that I'm using is, well, it's a bit unique. So I think we're running right now. Let me just pull this thing up really, really quickly. Let me just give you a quick run and it'll go off and look at it and see it turns it off and then it runs and then it loads up all the code. I have a lot of code that I've written and not a lot actually running, but just some code running. There it goes. Oh my gosh, I'm dying right here. There you go. You can see it running. Okay. What's happening? I don't know what just happened there. I think I'm gonna die. Anyways, you can see right here, this is my FPS right now, which is pretty good, right? So we're getting about that. It's not doing a whole bunch of changes, but it's making a whole bunch of changes as fast as possible. So you can see I'm doing about 700. This number, don't worry, I've been doing some refactoring. It would also say, it would say a large number as well, but right now it's not. The big thing you got to look at is this thing right here. So how am I doing things? So in hardware land, at least on this device, there's two RAMs. You have this like internal RAM, and it's like super fast. And then you have something called PS RAM. I don't know what PS stands for, but it's out there, okay? PS RAM. It's significantly slower, like order of magnitude slower, but it's also like it's just like gigantic comparatively. Here's the problem. My screen is 300 by 20 or 320 by 240 pixels. I wanted to have 16-bit color, and the whole purpose of this is so that my kid can make a game that's like Steal a Brain Rot off of Roblox, but something he can just kind of play offline, and he can make all of his own art for, and we can kind of decide on a bunch of the fun stuff together. And so that was like the purpose of this project. The problem is that when I take these two numbers together, it's approximately 150K, which I have more than enough DMA memory for this to actually happen. But unfortunately, I can only store about 110K contiguous, meaning that I cannot fit my screen into a single region. But even more so, when you're drawing stuff, if I were to draw just a full screen every single time, I'm getting like 29 frames per second. It's not very, very fast. And so I had to do a bunch of like fun tricks to make this happen. So one of the first things that I did that I think is actually really, really cool is that what I do is I define a couple things. I define my screen height and width, and then I define this like screen region. So I'm kind of using the same idea that like NES or SNES did, but they were obviously bound for a completely different reason. But I'm using the same idea, which I say, okay, I will do 8 rows of the screen as a region, and then that region I will repaint if something within it changes. And so then at the very bottom, I have this whole idea of a scene. And a scene is just simply that many regions and then that many dirty things and then this many objects and then object count. And so now I kind of keep track of my scene. And when any of the lines change, whenever I draw an object and it's drawn on any of those lines, then I can say, hey, this is dirty. So that way I'm writing to the fast RAM, but the fast RAM's been split up a whole bunch, so I don't run into this problem. You'll notice that even when I launched it right here, I don't know why I keep going to my calendar, but every time I launch it right here, you'll notice that my largest DMA free is like 40K right now. So I was able to just really precisely use very, very small amounts of contiguous data, whatever 8 times 320 times 2 is, 16 times 320. So pretty awesome. And here's another cool trick that I got to do. Every time you write to the screen, you get to use this thing called DMA, direct memory access. And when I write to the screen, what I can do is I can take this like memory region that I have, and then I can map it to the LCD, but it happens asynchronously. So by me making a bunch of rows over and over and over again, what I can do is I can spend an entire update cycle going through here and actually like writing to the actual internal RAM, get everything nicely set up in the internal RAM, and then I can shoot off each one of these rows that have changed over to the LCD. But then here's the best part. Because it's asynchronous, I can do the update again, and then I can wait afterwards for the drawing to be done. So now I can actually do an update and a draw at the same time. So that way I can kind of keep going pretty dang fast. And so right now, that's why I'm able to achieve about 700 frames a second on this. But obviously, I'm not doing very much at all on this one. I'm only changing like maybe 24 pixels at a time. So, or 24 height pixels at a time. So whatever 24 times 320 is at a time. So I'm changing very little, but I'm making it happen super fast. And so here's the idea of the game is that now what I can do is I can keep track of all my scene objects. When a scene object moves, I'm then able to take that moved scene object, determine that it's changed, and then be able to go, okay, I need to repaint this area. So that means I can mark everything as dirty vertically, and then try to paint the whole screen and only paint the things that have changed in the internal memory. Then Z layer on everything, only the things that have changed. So I'm even doing minimal amounts of writing into the internal RAM because I'm only writing on bands that have changed. And then boom, send it all up. So how I accomplish this is probably what you guys are really more excited about, is I kind of create a few things. So I haven't done anything with the Z ordering yet, but I did create this fun little enum, which actually is super useful. So I have this idea of a scene object. A scene object is either a piece of text, just a set of pixels, or an asset. An asset's really just a set of pixels with some like boundaries and all that other stuff. That way I can have stuff I can load from like say a file versus something I just handcraft in memory. They're just two different style of objects. Okay, now here's the real thing is how do we actually do this? Well, the first thing I do is I actually create the first, let's see, how do you want me to do this? First thing I do is I create the scene, right? Pretty straightforward. Create a scene, go over all the regions. I set where each region is, and then I create this thing called the TFT sprite. This is like a super sweet library for communicating to the LCD. And so I make sure that I can create the pointers. I make sure that I can actually allocate it. Like, hey, you better be 16 bits per pixel, and you need to be this big. So make sure I do all that, make sure I can allocate it. And then I set that, and boom, we're looking good, okay? And then I set how many objects we have. We're a fresh new scene. Now, I haven't used any of the scene objects inside the scene yet because I have some ideas, but we're gonna get there. So how do I do this? This is like the mainstay function. So this one doesn't draw to the screen, it just draws to RAM. And so how that's done is that I say, hey, I go through every single region from top to bottom and say, hey, is the thing I'm drawing within this region at all? And hey, by the way, here's a really cool thing to do because often this is kind of like a hard problem, right? Is that you have like a big screen and then you have a small little object right here, and then you have these like, these vertical slices, right? So you have to determine which of these are I in. I'm in these three, but how do I determine that? You have to do these like AABB stuff, and the math can get kind of wonky. But what I realize is it's just really contiguous memory, right? So you can kind of just treat it in a one-dimensional type of thing. So I just say, hey, I start in this row, I end in that row. Where my region is starts in this row, ends in this row. So long as either my start point of my object is outside of the region and my end point is within or past the region, or the inverse, hey, we're good to go. We're within. So you can just do this really nice little simple comparison right here. Makes me feel very happy about that. And if I was actually like super ultra duper concerned, I'm sure we could even move out these calculations into something that's a little bit more efficient, but I'm not too worried about updating. I'm actually most worried about drawing to the screen. That appears to be my upper bound. I can change about whatever this number right here. This is about how many rows I'm changing per second. I can change about that many pixels per second. Whatever that equates to, 717 times 320. That's about how many pixels I can change per second. And it seems to be a pretty consistent, repeatable number that I can do. Like, so if I increase this, watch this. See how small that is? If I just jump here and I jump right. Oh yeah, let's go up here. Let's go up here. Let's just increase this to say 16. And then I rerun this. Hopefully this just works. Like maybe did I just actually make this good enough? I don't know. You'll notice that, oh, well, I mean, it's building. Will I actually get a hard crash? We don't even know. But if I do this, you'll notice that, hey, look, my FPS dramatically dropped practically in half, even though I'm doing the exact same thing. And that's because I'm just drawing bigger regions. I'm really just pixel bound. There's some sort of update pixel bound nature somewhere in there that I'm not really quite sure what the problem is. And so I could even make it smaller, right? And if I do this, theoretically, this will even be faster considering the things I'm drawing. Uh-oh. 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 What did I do? Let's just see what happens. There you go. Look at that. It's like even faster. Now we're up to about 1,000 frames a second. Okay, splendid. But I don't know if that's actually going to hold true when I actually have the game in there, the Steeler Brain Rot style game. So anyway, so let's just jump back in here and let's take a look at the stuff that I think is interesting. So whenever I'm drawing something, I'm going to be pushing an image into it. Now, here's kind of like the cool part is with TFT, let's say I had a region that's defined like this, but I had something that I'm drawing that looks like this. With TFT, if I can say relatively this thing is, so we'll just call this thing as say like XY. So this region starting point is XY, and this one is say X prime Y, and Y prime Y is where I'm drawing this one. If I simply do something that looks like, y prime minus y equals where my starting y is going to be, then guess what? This will be a negative number, but I can do that and TFT will correctly not draw any of this, just draw this portion of the image and then not draw any of this. It's actually a really nice little library. It makes a lot of that like kind of, that's just a bunch of math that's going on underneath the hood. Like I could just raw dog the pixels, but it's such a boring and very tedious thing to get correct. And they already got it correct for me, so I don't need to think about it. So that's how I do it. I just go, okay, here, this thing's positions right here. This is kind of your starting offset. Draw it, and it just draws it correctly. It's beautiful. It really, really works. And so I can do the same thing with drawing text onto the sprite. I can push an image onto the sprite. I can push that raw pixel object onto the sprite. That's how the pixel objects, how I'm doing these things. That's actually why I built that little method, is just purely for this little example test. And so now I can just go through and do this. And if for whatever reason I have a tag that I don't recognize, they do a nice hard assert for me. You know what we're talking about, that nice NASA style coding, so I can ensure it. I also do all pre-allocation beforehand, right? So I can have max scene objects of 100. Like this just cannot happen. We will not have more than 100 scene objects. All that fun stuff. You can see it's all made in there. It's actually really nice to kind of go about and do all this fun stuff. But at the end of the day, that's how I determine if something's dirty. If any of these change, I can then push all this image in here, and then I mark this thing as dirty. So when I actually do the sending to the screen, I can say, hey, push this image to the DMA, and then I grab that region's data right there. So now that gets pushed off to this like automatic direct memory access pushing to the screen. And then in the actual like main file, when I'm doing this, I can go, okay, hey, we're going to start writing to the screen. I swap bytes because big endian, little endian, I'm not really sure endian. Who's endian sitting where? We don't know what's going on. When I was in MSU, Montana State University, by the way, go Bobcats, I thought that Indian stood for Indian. And so I was always really confused. Why are there big Indians and little Indians? I didn't really understand what was going on. Not until I read it later. Anyways, so then I do this DMA wait. So this is how I accomplish the old asynchronous coding, is that at some point, draw random squares right now is going to be my screen pre-render, which I'm going to probably rename to screen update. So my draw random squares goes in here and draws all the scene objects. I don't want this. This is just for test code, just to make sure everything actually works before I just full on write everything. So now I can do this nice little, hey, we're going to draw everything, and then I can wait. So my previous render then has to finish, and then I can start going again, which is actually pretty dang fantastic because everything just seems to be working, and it just seems to keep writing, and it seems to keep going very, very fantastic. I'll probably have to do a bit of double buffering somewhere within this whole universe, but right now it seems to be beautiful, and this seems to work fantastically. Anyways, I just wanted to yap about that. I think this has been a pretty fun little project. I'm pretty happy with everything I'm building. I cannot believe this is all actually working because, like, look at this. It's actually just it's doing the things it's supposed to be doing. So I'm very, very happy about that. And I don't know if this is all going to work out, but this is my first real attempt at trying to make something that can reliably draw a whole bunch of stuff and draw it pretty well. And it seems like I've done the exact thing I need to do. The next big thing will be me obviously having to create all the objects in the actual game, which I already wrote the game once, but it was super shoddy. And I was doing like 32 by 32 tiles and doing this really I mean, there was so much logic. It's before I started using TFT to actually do the drawing, and it was just like, oh my gosh, this is such a nightmare. All the interfaces were just so awful with like destination, starting point, destination, start or source, starting point, source width, and you had to do like all this stuff. And man, it was just such a nightmare to draw, to write all of those rectangle filling algorithms. But now it's just like so simple. It's just like, man, I've written like 150 lines of code. This will probably get up to like 250 lines of code, and then I'll be done. Some things that I have that I've talked or I haven't technically talked about or addressed is that the really hard ones, but I think I already have exactly how to do it, is let's say you have a screen, right? And you have an object go from here to here in a single frame. Well, what's the problem? Well, currently on the screen, wow, look at that. Did I just one shot the straightest line in the universe? I think I did. That one's not as straight. You can see a little bit of bend there, but it went from here to here. Man, damn, I'm on a roll right now. And so by doing that, I have to redraw this square. But if I only just have my scene objects, I only know about them right here. So I'm going to probably figure out some fun ways to do this right now, how I'm approaching it, which is probably not the right way to do that, is I have this function called like scene object or scene update object position. And then I will say, hey, scenes changed in this position and in this position. So I take its old one, mark all the rows that it intersects as changed, and then the new position marked all of its rows as changed. And that simply just goes over all the region counts, see which one intersects, and then marks that row as dirty. Is this the best way to do things? Probably not. Is this how we're doing them? Yeah, that's how we're doing them. Whoopsie pupsies. Anyways, so I hope that you guys enjoy all this. It's going to be pretty fun to do this thing. I don't know. The reality is I'm having a great time, and I get to make a little game for my son. And hopefully my son does that. By the way, also, as part of the game, it's pretty cool. I thought this was pretty cool, right? I don't know. Maybe you guys don't think it's pretty cool, but I do have this thing right here, which is I actually launched my own server, and I used Phoenix. Phoenix is fantastic. I really enjoyed using Phoenix. And so now he can upload his own little assets right here, and then that way it will show up for him, and he can mark them as his different level of rarities for brain rot, legendary, mythical, divine, relic. He came up with those names. So, hey, why not, right? It's going to be a lot of fun. And not only that, but I also wrote this fun little image generation thing in Elixir as well, where I parse out the pings, and I parse out what is uploaded to this site. And then I create a giant C file with all the data in it. And so if I go to generated, you can see all the images he's created that are just put right in here. I don't know. I thought it was fun. We'll see how far this goes because this might not go. Do I need to run RLE? Do I need to run some sort of compression on it and then only inflate the ones that I'm actually using? I don't know. Bunch of questions. We still haven't got there, but this has been a great time up until now. Just wanted to give you guys like a little quick update, kind of what I'm thinking, how to do all these things. I highly suggest playing around with a little bit of hardware. Hardware is super fun. And then the obvious other thing that I'm going to be doing in my more free time, which, this is kind of the bonus, is that I'm going to be really working on this thing right here a little bit more, which I find to be like kind of my passion fun project. So I go like this, little server right here. This opens up this beautiful Strudel website for some live music, right? I got to get that thing so it automatically closes. It's not closing currently. And then I jump in here. Let's go up to this thing. And let's go up to a nice little simple example. I have a little bit of music when I save it. Oh, you guys can't hear this, can you? Oh, you can hear this. So I can write in Vim, play in the website. And so I want to make it so that it's even more ridiculous, right? I want to be able to make it so that I actually have files, and I'm just like, hey, this is a 16, I want to make it so that like Vim automatically formats everything. So when I say like X, it's just like it will like correctly draw it in the scales and everything. So I don't have to go through here and try to play the game of ASCII art to be like, okay, here we go. This is ASCII art. Okay, here, you know, like I don't want to do that. I don't want to do that. It's not for me. But pretty cool, right? Right? We'll see how far this one goes. All right. That's all I wanted to say. Bye, Vimogen. Hey, if you guys like and subscribe, I don't know if you know this, but if you go to YouTube and you go the Vimogen, well, I'll be able to get my 3rd silver plaque. I know I should start uploading videos, honestly, because I last video was like 6 months ago was my last video. So I'm going to start trying to do this weekly, okay? Just kind of talking about what I'm building, what we're doing. Tell me if you like this. Leave some comments. What didn't make sense? What makes sense? What do you wish I did more stuff on? I didn't want to go too deep because, I mean, eventually, like, I don't want this to be a tutorial. It's more like I just want to yap with you guys. All right, bye.